Hi, I'm Mikey from the DLASC, and today I'll be going over trigonometric integration and derivative rules. So, to start, what is a derivative? Well, a derivative is essentially the first form of calculus that you learn, and it has specific rules. Specifically, the way that you take a derivative is that you take your number, or you take your variable, x to the power of n, and it becomes n times x to the power of n minus 1, right? So we have, we have x to the fourth. It becomes 4x to the third, because 3 is 4 minus 1, right? But we can't exactly apply these rules universally, right? There are several rules that we have to help us. There's things like the product rule, we have the chain rule, we have the power rule, all kinds of rules like that. And today we'll be talking about the ones that don't exactly have rules, the ones that you kind of just have to memorize. And that's why I'm making a video on it. So if you give me 1 second, we can go ahead and move to describing what these are. Derive into cosine, right? Which means that this is circular, right? Because we start at sine, we go to cosine. Cosine is right here, and cosine goes to negative sine. So the order in which we have these is, it's a circular order that starts with sine x, goes to cosine x, goes to negative sine x, goes to negative cosine x, and then starts back off again at sine x, right? And that one seems pretty easy, right? That's something that we absolutely understand, right? But when it comes to some of the other ones, some of the other rules are not as easy to remember, because those it involves two separate identities that will both interact with each other. But the rest of them are not as easy, although they do share somewhat of a structure. So, we will take tangent, for example. So, tangent x moves, whenever you derive it, tangent x moves to secant squared x, right? And the inverse of tangent, or cotangent, becomes negative cosecant squared x, right? And we can see that this is similar to these two. Well, secant being the inverse of cosine, and cosecant being the inverse of sine, right? 1 over sine x is equal to cosecant x. So we can see that these are related as well. So you would not be shocked to say that the inverses of secant and cosecant are also related. So let's go ahead and take a look at those. So the inverse of secant, it goes to, or not the inverse, I'm sorry, the derivative of secant turns into secant x tangent x, which, I can see the resemblance here. I can absolutely see how this secant and this secant x tangent interacts because of this resemblance right here. And for cosecant, the derivative is negative cosecant x cotangent x, right? And I can also see the resemblance here, right? We understand we have this negative, we have cosecant on one side, or two cosecants and one cotangent, and we have two cosecants and one cotangent. It's just all about rearranging it within your mind, right? And that is, kind of the basics of derivative rules for basic trigonometric identities. Again, my name is Mikey from the DLASC, and thank you for watching.